The final term is the pairing energy term. So nuclear data shows that the nuclei with even Z and even N are the most stable. So those nuclei which have even number of proton and even number of neutron, like we have already discussed, for example helium, okay, one isotope of lithium, okay, another isotope of carbon, etc. Nitrogen, N74, okay, etc. have equal number of proton and neutron, and they are the most stable. And those with odd proton and odd neutron are the least stable. Okay, the nuclear stability, the stability of the nuclei with even proton and odd neutron or odd proton even neutron lies in between. Okay, so even proton neutron are the most stable. Odd proton odd neutron is the least stable, and one even another odd lies in between. Okay, their stability lies in between. Okay, so this pairing of neutron and proton affect binding energy. Okay, so naturally those are most stable, they have greater binding energy. Those who are least stable, they have the least binding energy, and the corresponding correction term is called the pairing energy term, BP, which is delta 0 AP divided by A to the power K. Okay, so where delta 0 is 1 plus 1 for even neutron, even proton, delta 0 is 0 even odd pair of neutron proton. Either neutron is even, proton is odd, or neutron is odd, proton is even. Then delta 0 is minus 1 is for odd neutron and odd proton. So this is delta 0 plus 1, this BP term becomes positive. Okay, if delta 0 is positive, BP term is positive. So it will contribute positively, it will increase the value of binding energy for even proton and even neutron. So those nuclei are more stable. Then if delta 0 is minus 1, then BP term will be negative. It will decrease the total binding energy term. Okay, so for odd those nuclei with odd neutron and odd proton number, those nuclei are least stable, because for those nuclei pairing energy term will be negative. And for those nuclei which have even an odd number of neutron or proton, for them, as you have just we have told that for those the stability lies in between, delta 0 will be 0. So for those there will be no term coming due to pairing energy, this effect. Okay, pairing effect, and for them the stability will be in between, the binding energy will also have some intermediate value. Now this Kp here, okay, so you will find that this value of AP and Kp are different. Okay, so if Kp is half, which is according to the modern nuclear data, for that AP value will be, AP is the pairing energy coefficient, AP will have a value of 12. Okay, and if Kp is 3 by 4, then AP will be 34, which is according to old data. So if you have difficulty remembering these two data, so you can use either one, either using the old data or using the modern data. So if you are using the old data, you have to use AP as 12, and if you are using modern data, you have to use AP as 12 and Kp as half, and if you are using old data, you have to use AP as 34 and Kp as 3 by 4. So finally we have the total binding energy term. The total binding energy term is EB, which is the volume energy term plus surface energy term plus Coulomb energy term plus asymmetric energy term, then finally pairing energy term. So BB is AB, AV into A. So you see it is positive, so it is increasing the binding energy, and other terms are minus, like this. It is the surface energy term with negative sign, means it decreases. Coulomb energy term, also negative sign, it decreases binding energy. The asymmetric term, the asymmetry in the nucleus decreases the binding energy. Then the type of pairing, it may either increase or decrease. Okay, so where we know delta 0 is plus 1 for even nz, delta 0 is 0 for even odd nz, and minus 1 for odd nz. Okay, and kb you can use either the new nuclear data or a modern nuclear data or the old nuclear data, whatever you may use anyone. Okay, so using this value, so you have to memorize this expression, and using this expression there may also be some numericals like the values of AV, AS, AC asymmetry, all the coefficients are given, and the mass number is also mentioned, and the proton number is also mentioned. So you have to calculate this binding energy, or maybe some these values are given, you are asked to mention, you will be asked to calculate any one of the term, like this Coulomb energy term, Z value, A value are given, AC is also given, you have to calculate the Coulomb energy term. So you have to memorize this entire expression.